Can you imagine an object so bright that it outshines an entire galaxy? Yes, we are talking about quasars being the brightest objects in the universe, and they are powered by supermassive black holes at their cores. These cosmic lighthouses spew out vast amounts of energy in the form of light, radio waves, and X-rays. In this video, we'll explain everything you ever wanted to know about quasars, from their origins to the present day. Quasars are incredibly bright celestial objects located deep within the vast expanse of space. The nearest known quasar to Earth is situated approximately 581 million light-years away, residing within the galaxy of the Ursa Major constellation. The reason for their intense brightness? They are powered by a tumultuous influx of gas spiraling rapidly into a massive black hole. And you know what's interesting? Quasars can outshine every other star in their galaxy, making them the real cosmic superstars. It's almost like they're the VIPs of the universe, some of the farthest and brightest things we've ever spotted out there. So how do we find quasars? Back in the 1950s, when astronomers were doing their radio surveys of the sky, they stumbled upon these mysterious objects. Most of the radio signals they picked up were linked to regular-looking galaxies, nothing too out of the ordinary. But then, there were these other radio signals that seemed to match up with something different. Some of these signals matched up with things that resembled ultra-blue stars. It seems pretty normal. But when they took pictures of these objects, they saw something strange. They were surrounded by these faint, hazy halos. Because they kind of looked like stars, and kind of didn't, they got this sophisticated name, quasi-stellar radio sources, which was then abbreviated to quasar. The secret behind a quasar's immense brightness lies at its very core: supermassive black holes situated at the centers of galaxies. These black holes possess masses that are millions, or even billions, of times greater than that of our Sun. As gas is drawn towards these black holes, it becomes heated and emits energy, resulting in a spectacular display of light. This process can be visualized as a swirling disk of matter, known as an accretion disk, which orbits the black hole and is responsible for most of the emitted light. Furthermore, these supermassive black holes exert a profound influence on their surrounding environment. They can heat a proximate gas and propel it away, functioning like colossal cosmic wind turbines. Their efficiency in converting mass into energy is remarkable. For instance, for every kilogram of gas that is pulled into one of these black holes, it releases an astonishing 10 million billion joules of energy. This amount of energy could power a metropolis like New York City for several years. What's even more amazing is that they play a role in creating new stars and galaxies. So, quasars are like cosmic multitaskers, making a big impact throughout the universe. Now let me tell you about some great quasars. The brightest in the cosmic block is 3C273, located in a galaxy in the constellation Virgo. It has a large-scale visible jet, which measures 200,000 light-years and is 4 trillion times more luminous than the Sun at visible wavelengths. APM ER8279 plus 5255 in the constellation Lynx is like an epic cosmic battery, producing as much energy as 1,000 trillion suns. These quasars are the rock stars of the universe, stealing the show wherever they go. But here's where things start to get interesting. These cosmic superstars don't just shine off into space. They have a real effect on the area around them. Take, for example, PKS 1354-113, about 3.5 billion light-years away. This quasar is heating up the gas in its galaxy to the point where it glows in X-rays. Aside from their beauty and displays of power, quasars can tell us more about how galaxies and the entire universe started and evolved. So, how did we learn about this cosmic force? Observations taken with the 2.5-meter Isaac Newton telescope and the 1-meter Jacobus Kapteyn telescope at La Palma in the Canary Islands. Now, what they actually discovered was interesting. The quasar they found has two light sources. One source is an accretion ring wrapped around a black hole that's over 1 million times more massive than our Sun. This ring emits UV and optical light. As this quasar pulls in surrounding matter, that matter breaks up and produces energy in the form of light, and all of this energy eventually falls into the black hole. One of the major mysteries surrounding quasars is why we mostly find them in the early universe. Astronomers are scratching their heads over this one. Quasars used to be more common back in the early days of the universe, but today, they're a bit of a rarity. Here's the exciting twist to the story. These cosmic giants could actually assist us in solving some major cosmic mysteries. Dr. Susanna Bisogni, from the Harvard-Smithsonian Center for Astrophysics, sheds some light on this. She mentions that way back in 1929, Edwin Hubble made observations that showed a connection between the distances of galaxies and their velocities. They used something called Cepheid stars to figure out those distances. Now the intriguing part is that there's still a big gap in our understanding, like a cosmic puzzle waiting to be solved. We're talking about things like comprehending how the universe is stretching and expanding. It's as if the cosmos has some secrets it's been keeping, and these cosmic powerhouses might just be the key to unlocking them. Fascinating, isn't it? Now, astronomers have been measuring the vastness of space for a while using Type 1a supernova, which are exploding stars that always shine brightly. They act like rulers in space. The brighter ones are closer, and the dimmer ones are farther away. We've learned that the universe is expanding faster and faster, and we blame something called dark energy for it. One of the key puzzles in the cosmic world is something called the duty cycle, which essentially refers to how often these black holes go through active phases. Scientists analyzed about 11,000 quasars using data from the Sloan Digital Sky Survey, focusing on those with redshifts of 2.1 or less. What they found is pretty interesting. They not only figured out the duty cycle, showing how often these black holes become active, but they also created something called a mass function to tell us how big these black holes are. Here's the intriguing part. They found that the duty cycle falls between 10 to the power minus 3 and 1 to the power minus 1. In simpler terms, it means that these black holes are pretty dynamic with various active phases. It's not a constant, it changes over time. What's also fascinating is how this ties into the story of how stars were born in the universe. It suggests that black holes are quite active during the star-forming process. So there's this intriguing connection between star formation and the activity of these cosmic black hole engines. Quasars, with their unparalleled luminosity and power, are among the most enigmatic and potent objects in the universe. They are believed to be driven by supermassive black holes and can emit light that outshines 1 trillion galaxies combined. Quasars also play a crucial role in the evolution of galaxies. While we have made significant strides in understanding quasars in recent years, they remain shrouded in mystery, and there is still much to uncover. As astronomers continue their research, quasars will undoubtedly remain at the forefront of astrophysical exploration. What do you think is the most important question that astronomers still need to answer about quasars? Let us know in the comment section, and don't forget to subscribe for more amazing videos.